So we got this as a triangle. Now the next question is saying, find its perimeter, area, and the size of its internal angles. Okay, so we have the sides BC. BC is 15, AB is 25. No. So it's supposed to be the other way. Yeah, it's supposed to be the other way. The longest side. Okay. So our triangle will be, we are still dealing with question 4. We are on B. After having found this triangle, we just discovered that the right angle triangle with this big 90 and then A B C. So this side was 25 and the side which was 20. Check. Side was 20 here. So AB was 25, AC was 20. So AC was 20, AC was 20, and this was 15. So find the perimeter. So the perimeter of ABC is equal to 25 plus 15 plus 20. So 25 plus 15 plus 20, that is 60. When we will just say 50 units, 60 units. Then find the area. The area of ABC is equal to half base times height. So it is half, base is 15, height is 20. So that we get 15 by 10, which is 150 units squared. Then find the size of the internal angles. As you can see, we are looking for the size of this angle. Let's call it theta, and this one we call it alpha. So how do you find the size of these internal angles? What do you use? Since it's not since the right angle triangle, I think something will change. It won't be like where we used to. I don't think we can apply sine rule direct on such an angle. Okay, suppose we applied sine rule, we'll get a proof if that is the case. So we know that A over sine A is B over sine B, which is C over sine C. That's the first thing. Or since you are doing the right angle triangle, we also know that there is this guy which says that sine theta is opposed over hypotenuse, or cos theta is adjacent over hypotenuse, or tan theta is opposed over adjacent. So let's look at our angles and see which one can work better for us. For theta, if we use sine, so you can pick one of these. Let's try to use sine. Say sine theta opposed is 20 over hypotenuse 25. We simplify, you divide by 5, we'll get 4 over 5. So in this case, this guy is sine theta. So theta is going to be sine inverse 4 over 5. Then alpha, if we use the same sign, we'll get sine alpha to be 15 over 25. Divide by 5, you get 3 over 5. And so alpha, because this is sine alpha, so alpha should be sine inverse of 3 over 5. Now, since these are not standard angles, then we'll be forced to use the calculator. So sine inverse, where is it even? Which is in shift, sine inverse of 4 over 5. 4 divided by 5 will give us the angle theta to be 53.13 degrees, and alpha should be sine inverse of 3 over 5, which is 36.87 degrees. So this is how we obtain the angles. Now I wanted to see, since for an open triangle we use this, what could happen if you made a mistake and thought that you can use the sine rule? So you will say, okay, I have the angles, since we know that this is 90 here. So you say I have the angles. I have a relationship of 25 over sine 90 and a relationship of 20 over sine theta. Then sine 90, we know it's okay, we cross multiply, so we have sine theta multiplied by 25 is equal to 20 sine 90, which is sine theta is equal to, sine 90 is 1, so you have 20 over of 20 over 25. So theta then, this is going to be 4 over 5. So theta will be sine inverse of 4 over 5. So it will land us here, because that is the only fixed angle that we have. So the same thing could work for alpha if you are using sine. But then if we went for cosine rule, that one will be a bit tricky, because now you can still find it, because we have C is given as the square root of A squared plus B squared plus AB cos C. So if you pick theta, then you're saying 20 is equal to the square root of A squared, or you pick 15 squared plus 25 squared plus 15 by 25, and then cos theta. So if we square and square, we'll get 400 on the left is equal to 15 squared plus 25 squared is equal to 850 plus 15 by 25, that's 375 cos theta. And then you take this other side, so you get 850 minus 400, that is 450, and divide by 375, you get 1.2. So cos theta will be negative 1.2. So theta is equal to cos inverse of negative 1.2. Let's see what comes out. What is cos inverse of neg 1.2? There is a math error. So you cannot get that law for cos. So it means that you cannot use the cosine. Oh, no, this is supposed to be minus here, not plus. It's a subtraction. So you can still use it. Let's just wait for the outcome. Minus, so this will be plus, plus. So get cos inverse of 1.2. Okay, still it can't work because there's not going beyond the 1 for cos. So you cannot use the cosine law, but you can use the sine. As long as you realize that the angle, there's a full set of angle given, which is 90 against hypotenuse. So you can use it to get the angle theta if you pick the other side. So this is useful. That is in a case where you forget that you can use SOHCAHTOA. But do you remember that you can use SOHCAHTOA? Even the best. So I have found the size of the angles inside, because the other angle is 90 already is known. And then we found also the other two angles. So we'll meet again tomorrow at the same time.
Wait, sir. I have a question.
Okay.
How do you know? Okay, how do you know when to? I don't know if that's what I'm saying, but how do you know when and when not to use the sine and cosine rule? Or maybe you still have to work it out, and then when you fail, that's when you know that you can't use it. Or is there a way that you can know that here you can use the sine rule and replicate?
So for the sine rule, you can use the sine rule every time you have. Remember that the sine rule will work in pairs. So if I have this is equal to b over sine b. So if I have an angle and it's the opposite side. And I also have another side whose angle I'm looking for. Then I can use sine rule. Cosine rule requires that if you have this thing here, if you have this, not necessarily 90. So if you have this, and you have an angle here, and this side is given, this side is given, the angle is given, and you want to find this side, you can use cosine rule. Or this side is given, this side is given, the other side is given, and you want to find the angle inside, provided that this guy here is not 90 here. Because we've checked for 90, it has failed. So here we're demonstrating to see if we forget this one, which other one can we use? So if you forget the SOHCAHTOA, you can use the sine, but the cosine will fail in a case where the angle is 90. That is
Okay.
So let's see how far we'll go tomorrow. I'm sure tomorrow we'll finish vectors, then we'll have to start looking at matrices. So we're remaining with two topics, matrices and probability and statistics. Hope to finish this month. Next month you're on your own. Good day.